A quadratic equation is an equation that can be written in the form ax squared plus bx plus c equals 0, where a, b, and c are constants and a is not equal to 0. To solve a quadratic equation by factoring, we first write the equation in standard form, with a polynomial on one side of the equation and 0 on the other. Next, we factor the polynomial. And then finally, we set each factor equal to 0 and solve the resulting equations to find the solutions of the quadratic equation. Now, this last step makes use of the principle of zero products, which states if a times b equals 0, then either a equals 0 or b equals 0 or both. In other words, if the product of two factors is 0, then at least one of those factors must equal 0. Let's do some examples of this process of solving quadratic equations by factoring. Our first quadratic equation is x squared plus 4x minus 21 equals 0. Note that this equation is already in standard form, so we can proceed to factor the trinomial. It's the product of two binomials, x plus 7 and x minus 3. Now we will make use of the principle of zero products. Since those two factors have a product of 0, one or the other of those factors must be equal to 0. So we can write two equations, x plus 7 equals 0 or x minus 3 equals 0. Our first equation has a solution of negative 7, and our second equation has a solution of 3. So if we're writing a solution set that contains all the solutions of the original quadratic equation, it should contain both numbers, negative 7 and 3. If we substituted either one of those numbers in place of x in the original equation, we would see that it makes the equation true. Let's look at a second example. 6y squared equals 9y. Now, it's important in a situation like this to avoid the temptation of dividing both sides of the equation by y. If we were to do that, we would actually obtain a linear equation. We want to solve this quadratic equation and find all the solutions of the quadratic equation. So instead, we should write this equation in standard form, and we can do that by subtracting 9y from both sides to obtain 6y squared minus 9y equals 0. We can factor the binomial on the left-hand side of this equation using the distributive property. We can factor out 3y, and then we have the binomial 2y minus 3. Since the product of those two factors equals 0, we can apply the principle of zero products. Setting our first factor equal to 0, we have the monomial 3y equals 0. And then our second factor is a binomial, so we'll set that equal to 0, 2y minus 3 equals 0. And now we can solve each of these equations. The solution to the first equation is simply 0. We can see that by dividing both sides by 3. For the second equation, we have two steps to isolate the variable. First, add 3 to both sides, then divide both sides by 2. So again, the solution set of our quadratic equation contains two numbers, in this case 0 and 3 over 2. Let's do two more examples. Notice that our third equation already has an expression in factored form on the left-hand side. However, the product of those two binomials is equal to negative 18, not 0. So we cannot apply the zero product principle yet. Instead, we need to rewrite this equation in standard form, and then we can use that property. So first, let's multiply the binomials. We would have n squared minus 7n plus 2n minus 14 equals negative 18. Then to write the equation in standard form, we can first combine those like terms. Negative 7n plus 2n is negative 5n. And then to get 0 on the right-hand side, we should add 18 to both sides of the equation. So now we have plus 4 equals 0. Now that the equation is in standard form, we can factor that trinomial. It's the product of the binomial n minus 1 and the binomial n minus 4. applying the principle of zero products, we have two equations, n minus 1 equals 0, or n minus 4 equals 0. And then we see two solutions. In this case, the solutions of the quadratic equation are 1 and 4. One final example, problem number 4. Once again, this equation is not in standard form, so let's work on putting it in standard form first by applying the distributive property. So we have x squared plus 7x plus 40 equals 15 minus 3x. Now let's gather all of our terms over to the left-hand side of the equation. First, if we add 3x to both sides, we'll have 10x. And if we subtract 15 on both sides, we'll have 25. And we'll have 0 then on the right side, so our equation's in standard form. Notice that we have, in this case, a perfect square trinomial, x squared plus 10x plus 25. So it factors into the quantity x plus 5 squared. And since our two factors are both the same factor, that binomial x plus 5, there's really only one possible way for this equation to be true. Applying that zero product principle, the only factor that could be equal to 0 is x plus 5. This means that the only solution to this quadratic equation is negative 5.